Mensuration. As we know, there are two major sections of the topic mensuration: plane figures and solid figures. Today I start solid figures, and in this video is part 2 of volume and surface area of solid figures. I start the chapter with concept of cross section. Let's start. Let's understand the term cross section. The cut which is made through a solid perpendicular to its length or height is called its cross section. The next term is uniform cross section. Definition is: a solid is said to have uniform cross section if this perpendicular cut is of the same shape and same size at each point of its length or height. Let's take an example to understand cross section and uniform cross section. I take an example of cuboid. You'll find that a shaded square area of this cuboid, which is shown here using red boundary line, is cross section of the cuboid. Parallel to this cross section, if you make many slices, then we observe that the new cross section obtained is again of same size and same shape of the first cross section. Hence, a cuboid has uniform cross section. Next example, let's take a cylinder, a solid cylinder. The circular surface shown here in shaded form and is bounded by red ring is cross section of the cylinder. And again, if we make many slices parallel to this cross section, or we say perpendicular to the length of the cylinder, then every new area formed is further equal in shape and size of the cross section shown here. Hence, a cylinder too has a uniform cross section. Let's take an example of a cone. Its base is a circle and it is shaded here. I am trying to show here that this circular base can be a cross section or not. Parallel to that circular base, or we say perpendicular to height of the cone, if we cut many slices, then we'll get circles of different radius. So this cross section is not uniform, or here in this case we say that there is no cross section available in cone. Next term is volume. The formula says that volume of a solid figure is area of cross section multiplied by its length. In case of this cuboid, as I said, this shaded square area is the cross section of the cuboid, and this line I am showing using arrow is the length of the cuboid. So the area of cross section multiplied by its length is the volume of the cuboid. Next term is surface area excluding cross section. So that is perimeter of the cross section multiplied by its length. And this surface area is the surface area of the object excluding area of cross section. The note says everybody cannot have uniform cross section, and this chapter deals with solid figures. having uniform cross section. And one more thing to say, that the volume and surface area of any solid figure can be found out using area of cross section if the solid figure has uniform area of cross section. Let's observe the example. It is clear here that cuboid and cylinder have uniform area of cross section. Hence, the volume and surface area of these two objects can be found out using area of cross section. But in case of a cone, since not having uniform area of cross section, then its volume and surface area we cannot find out using area of cross section of the cone. Let's take this question. Question number 5. It says a swimming pool is 40-meter long and 15-meter wide. Its shallow and deep ends are 1.5-meter and 3-meter respectively. If the bottom of the pool slopes uniformly, find the amount of water in liters required to fill the pool. Observe the diagram here. Let's take the diagram which is of 3D look. In this diagram, 1.5 meter shown in the diagram is the depth of the shallow end. This one, 3 meter, is the depth of the deep end, and the pool is 40-meter long. The width of the swimming pool, that is 15-meter, and this particular length says that the pool slopes uniformly. Front surface is the area of cross section, and this area of cross section multiplied by width, that is 15-meter, gives volume of the swimming pool. Since the area of cross section here is a trapezium, hence by formula its area is half multiplied by sum of parallel sides multiplied by distance between them. In this formula, 1.5 meter and 3 meter are parallel sides of the trapezium, and 40 meter is the distance between the parallel sides. After simplifying this expression, the result obtained is 90 meters square, and that is the area of cross section of the swimming pool. Now to find out the volume of the swimming pool. And since area of cross section is there, hence the volume of the swimming pool is area of cross section multiplied by its width. Here is the expression for volume of the swimming pool, where 90 is the area of cross section of the pool and 15 is the width of the swimming pool. The result obtained is 1350 cubic meter, and that is the volume of the swimming pool. It means this much amount of water is required to fill the swimming pool, and the same volume can be represented in liters if asked in the question, and the value is 135,000 liters. Let's take next question. Question number 6. It says the following figures shows a solid of uniform cross section All the measurements are given in the diagram in centimeter. Find out the volume of this solid figure and total surface area. In the diagram, the front area shown here using red boundary lines is the area of cross section of the object. To find out the area of cross section, this cross section has to be divided in two parts or two rectangles. Now this cross section is divided into two rectangles, and the area of two rectangles are 9 multiplied by 3 and 6 multiplied by 3. Finally, the area of cross section obtained is 45 centimeter square. The volume of the figure is area of cross section multiplied by the thickness. The expression is 45 multiplied by 4, where 45 is the area of cross section of the solid and 4 is its thickness or width. The result obtained of volume of the figure is 180 centimeter cube. Next is perimeter of the cross section, and here I start taking perimeter of the cross section from the bottom left corner in clockwise direction. So perimeter of the cross section is this one 9 centimeter plus this one 3 centimeter plus this one 6 centimeter plus this one 6 centimeter plus this one 3 centimeter, and at last this particular one is 9 centimeter. Finally, perimeter of cross section is 41 centimeter. Now comes total surface area, and the expression is perimeter of cross section multiplied by thickness plus 2 times the area of cross section, because in the expression, that is perimeter of cross section multiplied by thickness, gives the surface area except the area of cross section. Well, 41 multiplied by 4 gives side, top and bottom area, and 2 multiplied by 45 is the area of cross section, that is the front one and the back one. Finally, the result obtained is 254 centimeter square, and that is the total surface area of the figure. Here I have put a tag to find out the cost of manufacturing the figure at the rate rupees 15 per centimeter cube. The expression for the total cost of manufacturing it is rupees 15 multiplied by 180, where rupees 15 is the rate of manufacturing the figure and 180 is the volume of the figure. The result obtained is rupees 2700, and this is the cost of manufacturing the figure. The next tag put in the question here is to find the cost of coating or painting it at rupees 2.5 per centimeter square. The cost of coating the figure is rate of coating multiplied by total surface area, and here in the expression rupees 2.5 is the rate of coating it and 254 is the total surface area of the figure. The value obtained is rupees 635. So rupees 635 is the cost of coating the given solid figure. Here is the next question, question number 7. It says water discharges from a pipe of cross-section area 3.2 centimeter square at the speed of 5 meter per second. Calculate the volume of water discharged. Number 1 in centimeter per second and number 2 in liters per minute. And the third part is find the time taken to fill the tank of dimension 2 meter into 1 meter into 0.8 meter. According to the question, the speed of water is 5 meters per second or 500 centimeter per second. In this expression, the volume of water discharges per second is 500, that is the length of the water flows out, multiplied by 3.2, that is the area of the cross section of the pipe. Therefore, the volume of water discharges per second is 1600 centimeter cube. And after converting centimeter cube into liters and second into minute, the result comes 96 liters in 1 minute. The third part of the question is to find out the time taken to fill the tank of dimension 2 meter into 1 meter into 0.8 meter. And the expression is volume of the tank divided by speed of water. The expression is 200 multiplied by 100 multiplied by 80 centimeter cube divided by 1600 centimeter cube per second. Now finally the time taken to fill the tank is 1000 seconds. You can convert it into minutes or hours too. Next question, question number 8. It says a rectangular tank of dimension 30 centimeter into 20 centimeter into 12 centimeter contains water to a depth of 6 centimeter. A cube of edge 10 centimeter is placed in the tank with its one face resting on the bottom. Find the volume of water in liters that must be poured so that the cube is just submerged. Initially, the volume of water in the tank is 30 multiplied by 20 multiplied by 6 centimeter cube, and when a cube is submerged, then the volume of the cube, that is 10 multiplied by 10 multiplied by 10 centimeter cube, gets added to that. And the result here is 4600 centimeter cube. This represents the volume of water initially contained in the tank and the volume of the cube submerged. Let's understand this statement. Since the cube is just submerged when extra water is added to that, hence the new height of water level is equal to the height of the cube, and that is 10 centimeter. It means when extra water is added to the tank so that the cube just gets submerged, then altogether the height is 10 centimeter. Hence, extra amount of water added plus the water already contained in the tank plus the volume of the cube altogether is 30 multiplied by 20 multiplied by 10, and 4600 centimeter cube is the volume of water and the volume of the cube already contained in the tank. Hence, the extra water to add is the difference of these two volumes. And the answer finally is 1400 centimeter cube or 1.4 liters. Therefore, extra volume of water needed to just submerge the cube is 1.4 liters. Here is your first homework on the topic solid figures. So try your best to complete the homework. I discussed part 2 of the chapter solid figures, which started with the concept of cross section, and some questions are discussed on solid figures having uniform area of cross section. I hope you understand these classes very well. In part 3, I'll take some more questions on the same concept. Thank you.